Good evening, guys. Today we are going to see the acid base related PYQS. Okay, so see here bicarbonate, PCO2, pH, sodium, chlorine are given. So from here we have to find anion gap. Okay, anion gap is equal to sodium minus chlorine plus bicarbonate. Okay, so see here sodium value 135 minus chlorine value 106 plus 7. 106 plus 7 113. 135 minus 113 is equal to 2 2 22. So anion gap 22. Okay, next see normal anion gap 6 to 12, right? So consider as 10, approximately 10. Okay guys, here we found that anion gap 22. Okay, normal 10. So next normal bicarbonate 20. We have to compare anion gap and bicarbonate all. Okay, so see normal bicarbonate 22 to 26. So approximately you consider this as 25. So here 7, right? So change, how many changes there? 10 to 22, so 12, and 25 to 7. 25 7 17, right? Right, only 25 7, sorry 18, right? Okay, so then we have to calculate CO2. That is approximate CO2 for this bicarbonate. Okay, actually for any value, for any sum, we have to find first anion gap, then bicarbonate, what's the change, then approximate carbon dioxide value. Okay, so for this bicarbonate, what the approximate carbon dioxide value? So for this we have to add 15 to the given carbon dioxide, sorry, bicarbonate. So 7 plus 15 22 plus or minus 3. So it may range 19 to 25, right? But the given carbon dioxide is 11. So it is below the expected value. So it is a respiratory. Carbon dioxide above means acidosis, which is below, so alkalosis. So we have find out one thing. Okay. Second, see the anion gap which is high. So high anionic gap. This is acidosis, right? So bicarbonate also low 7. So metabolic acidosis. Okay. Okay. Next, plus see here for anion gap it is increased up to 12. So bicarbonate also it should be decreased up to for 12, but it has decreased 18. So here we have to consider bicarbonate and chlorine. So some anions are increased, right? So that it is decreased further. So this is normal anionic gap metabolic acidosis. So the given answer here is high anionic gap metabolic acidosis plus normal anionic gap metabolic acidosis plus respiratory alkalosis. Okay, now we are going like a brief. Okay, first we have to find anionic gap. For anionic gap formula, sodium minus chlorine plus bicarbonate. So sodium minus chlorine plus bicarbonate, so we get 22. Okay, keep it here. Then write the below bicarbonate value and see the change for anionic gap, how many change, and bicarbonate how it changed, from normal value how it changed. Then find out the expected carbon dioxide. Okay, so from here we can find respiratory acidosis or alkalosis. Then for anion we can find out this, and from here we can find out this. Okay, bicarbonate. Okay, first question solved. Then second question. Okay, here so first we have to find anionic gap, right? Anionic gap. Actually you think like that, anionic gap, bicarbonate, yes, CO2. So we have to find out like that. Okay, so anionic gap, sodium minus chlorine plus bicarbonate. So 135 minus chlorine, which is 104, plus bicarbonate 4. 104 plus 4, 108. 135 minus 108. Sorry, 27. Okay, 27, right? Right. So anionic gap 27. Next, bicarbonate given value 4. So write the normal value 10. Anionic gap normal 10. Bicarbonate normal 25. What's the change? Here it is changed 10, 27, 17. Here 25 for 21. Then expected carbon dioxide. From bicarbonate value we have to calculate, right? So carbon dioxide, expected carbon dioxide is equal to bicarbonate plus 15 plus or minus 3, right? So carbon dioxide, that is bicarbonate 4 plus 15 plus or minus 3 is equal to 19 plus or minus 3, 16 to 22. So 16 to 22 is normal. That is expected carbon dioxide. But the given carbon dioxide is 42, which is above the value, right? Carbon dioxide is acid. If it is above, means respiratory acidosis. Okay. Then see, here you see anionic gap, which is increased. So high anionic gap, pH is 7. Metabolic acidosis. That is bicarbonate also 4, right? So metabolic acidosis. Okay. Then here you see anionic gap is increased. That is anion is increased up to 17 times. So bicarbonate, which is also 21 times, but it should increase up. That is, it should decrease by 17 times. But here it is 4 times more than anion gap, right? So some it is increased. That is bicarbonate is decreased. Positive is decreasing. So some chlorine anion should have been added, right? So normal anionic gap, metabolic acidosis. See, now I'm going to see why I'm saying high anionic gap metabolic acidosis and normal anionic gap metabolic acidosis. See, the anionic gap formula is sodium plus minus chlorine plus bicarbonate, right? So if here anionic gap is increasing, okay, sodium neutral, okay, and chlorine, which is also normal, but bicarbonate is decreasing. If here bicarbonate is decreasing, right, sodium always a neutral value, so bicarbonate is decreasing, so the anionic gap absolutely will be high, because chlorine is an anion, right? So it's neutral, but the positive is decreasing, so anionic gap will be high. So it's high anionic gap metabolic acidosis. For normal anionic gap, the anionic gap should be normal, right? Sodium neutral. If acidosis means we know that bicarbonate should decrease. So bicarbonate is decreasing, but here some another anion also increasing, that is chlorine also increasing. So it will become neutral. So it's normal. If it is decreased by 5, chlorine is increased by 5. So 0 for normal anionic gap. Okay. So this normal anionic gap metabolic acidosis. So here also see bicarbonate is decreasing, but it should decrease by 21. But that means it should decrease by 17. But it is decreasing 21 times. So some anion also increasing. So chlorine increasing, bicarbonate decreasing. So it's a normal ionic gap metabolic acidosis. Here see ionic gap is increased because of bicarbonate is decreasing, right? So it's a high ionic gap metabolic acidosis. Okay, I think so you have understood some. I also understood some. Okay, thank you guys.